Okay, this next outcome is where students will demonstrate understanding of factoring, concretely, pictorially, and symbolically. To be a level 2, you will be consistent with factoring 2 of the 3 types of polynomial factoring that we are going to do in this course: greatest common factor, trinomials, and difference of squares, where there is only one method to the question, so there's not multiple steps. To be a level 3, you will be consistent with factoring polynomials where there is only one method to the question, and you'll be able to perform the first step in a multiple strategy question. To be a level 4, you will be consistent with factoring polynomials of all types and any number of steps. You are able to perform error analysis, and you are able to explain the relationship between multiplying and factoring polynomials. Some terminology to look at when we are dealing with algebra. Factors are 2 expressions, 2 polynomials that are being multiplied together. Could be 2 or more. So it's polynomials that are multiplied together. An expanded form is an expression that forms the product when you multiply those factors together. Factoring and expanding are inverse processes. In arithmetic, we talk about multiplying factors to form a product. So 4 times 7 equals 28. But in algebra, we talk about expanding an expression to form a product. In arithmetic, we talk about factoring a number by writing it as a product of the factors. So 28 equals 4 times 7. But in algebra, we talk about factoring a polynomial by writing it as a product of factors. Factoring and multiplying are inverse processes. We can use this to factor a trinomial. When a trinomial contains only positive terms, we may use algebra tiles to factor it. For example, to factor v squared plus 12v plus 20, arrange the tiles that represent the terms in a rectangle. Place the v squared tile in the top left, then arrange the v tiles to the right and beneath this tile so that the 1 tiles fit in the space that is left. So for example here, we now want to look at what the dimensions of each side are. We have a v tile, plus we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1 tiles. So we have a dimension of v plus 10. Along the side, we have a dimension of v plus 2. So our factors are v plus 2, v plus 10. This is great for visualizing what it means to factor a polynomial. However, it only works when there are positive terms. So we need a strategy for when they are not all positive terms. One possible strategy is to use the box method. This is not the only strategy out there, and we will look at different types throughout this outcome. However, for now, we're going to start with one that will work for all types of factoring in this course, except those that require greatest common factor. Although it will work for all types, it may not be the most efficient method. So you may end up looking for a better method, or if you're a person who struggles and it takes you a lot longer to learn methods, this would be one you might want to learn, because then at least it will get you enough to do a level 2 for this outcome. So here's how the box method works. We draw ourselves a little box. In the first column, we are going to take the first coefficient, which is 1, and we are going to write a set of possible combinations of factors. Now, the only possible combination of factors for 1 is 1 and 1. In the second column, we take our constant term, which is -8. We want to write a possible combination of factors that multiply to 8. Now we have 1 and 8, or 2 and 4. A general rule of thumb, because this is trial and error, is to start with the 2 that are closest together. So that would be the 2 and the 4. They are closer together than 1 and 8. So now what we do, don't worry about the sign right now, we will take that into consideration in a moment. We do a diagonal multiplication. 1 times 2 is 2, 1 times 4 is 4. Now we ask ourselves, is there any way that 2 and 4 can be added or subtracted to get this middle term value, which is -2? The answer is yes. 2 subtract 4 would be -2. So now we've got that negative with the 4. because this 4 was part of the diagonal multiplication here, the negative goes with the second column value on that diagonal. The 2, so it will stay positive. The variables that we are dealing with in this question were x's. Those will go with the first term, the first column. Now we have our 2 factors, and we get our factors from within the box, not these numbers that are on the side. So what we end up with is we end up with x plus 2. We do not have to write the 1 with the x, and x minus 4. Those are your factors of x squared minus 2x minus 8. You can double check your work by multiplying those back out and seeing if you get the original trinomial. Let's try another example. Draw ourselves our little box. Coefficients of the z are 1 and 1. Possible factors of 35, 1 and 35, 5 and 7. 5 and 7 are the 2 that are closest together, so those are what I'm going to start with. Let's do a multiplication across the diagonal. 1 times 5 is 5. 1 times 7 is 7. Can we get to negative 12 by adding or subtracting these? The answer is yes, if we make both of them negatives. And this should make sense. A negative times a negative will give us that positive. If we were multiplying out our 2 factors, that's what we would have to look at. So they are both going to be negative values, and we are dealing with these. From within the box, we have our 2 factors, z minus 5, z minus 7. It does not matter which order you write the factors in, as long as the appropriate signs are with each term. Let's look at C here. Some of you may attempt to solve C right from the order that it is in. That's okay. It'll take a little bit more thought to do, but it can be done. What you may want to do is rewrite it so that your squared part is first and your constant is at the end. Just make sure you move the signs appropriately. So now when we do our box method, coefficients of the d squared are 1, so possible factors are 1 and 1. 24 has 1 and 24, 2 and 12, 4 and 6, 3 and 8. So we said to start with the ones that are closest together. 4 and 6 are closest together. Multiply across on the diagonals. Can 4 and 6 be added to get negative 5? Hopefully you've said no. That one doesn't work. And this is where there is a little bit of trial and error. That's also why we said to start with the 2 that are closest together, because that will work probably 90% of the time. In this case, it didn't. So now I need to try another set. My next 2 that are closest together are 3 and 8. So I'm going to try them. Multiply on the diagonal. 3 and 8. I need negative 5. If we make the 8 negative, 3 subtract 8 is negative 5. So the 8 needs to be negative. We are dealing with these. Take from within the box. We have d plus 3, d minus 8. Last example. Hopefully by now you're understanding the process, or it's becoming a little bit more clear. The hardest part, once you understand the process, the hardest part sometimes is finding those factors. Which factors multiply to 24? Which factors multiply to 30, or whatever the number might be? Sometimes that is the hardest part here. 1 and 1 again. Coefficient on m squared was 1. Factors of 60. There's lots of possibilities here. Maybe if we want to try our 2 that are closest together, we may not get the value right off the bat. For a large number like this, you might want to write some of the possibilities out. We've got 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, and that is it. So if we were to try the two that are closest together, 6 and 10, some of you might already recognize that's not going to work. Save yourself some time if you can visualize them in your head. That is just not going to give us -7. Try 5 and 12. We got 5, we've got 12, we need -7. It works with a -12. Notice you can always do a quick check on your signs too. So now we're saying we have a +5 and a -12. A positive times a negative gives us that last negative. Make the 12 negative, make the 5 positive, put m's in your factors, and we end up with m plus 5, m minus 12. And that is the box method that can be used for each of these. Now, as you're going through them, there is a more efficient shortcut that can be used. I'm not going to show it to you right now. I want you to learn the box method. If you find the shortcut on your own, you are more likely to remember it. So look for it as you're doing the practice assignment.